When I first published SuperHTML, I discovered that it was the first ever HTML language server that reported diagnostics to the user. I wrote a blog post about it, and it got on the front page of Hacker News, and nobody corrected me, so you know it's true. I originally found it a funny thing, but thinking about it more, it's a bit sad that this is the case. Linters do exist, and people can get diagnostics in their editor, but that's usually tooling tied to a specific front-end framework, not vanilla HTML. Which leads to people opting to use frameworks, even if they don't really have a need for all the complexity that those frameworks bring.
Give it up for Loris.
Thank you. Okay. Hello, everybody. So yeah, I'm Loris. I'm VP of Community at the Zig Software Foundation. Here you can find a link to my blog. I have a YouTube channel. I also live code on Twitch, so if you ever get Zig curious and you want to see somebody do some Zig or ask questions, feel free to join me. I also happen to have written a language server for HTML. This by itself, I don't think is all that interesting. I think what is more interesting is the context that led me there. And also, I will try to, as I tell you the story, to share with you all the things that I learned along the way, so that if you happen to walk a similar path to mine, you might, skip some of the things, do faster some of the things that took me a while to realize. That said, talking about like the product itself, it's on the VS Code marketplace. It's not only VS Code, but obviously I'm imagining a lot of people use VS Code. So if you want to download it, you can just search for SuperHTML. In there, I'm not saying this only to inflate my download numbers, but also so that, if you get bored and want to try it out as I speak, feel free to do that. And if you're too lazy, that's kind of what it looks like. It literally just puts squiggles in your editor. Also, if you find some of these HTML errors surprising, we can talk about how weird HTML is later on. So let me start from the beginning. I've written an HTML language server because I'm writing a static site generator. Like most people, I started my first static website was my personal blog. And at the time, which was a few years ago, I remember my top two choices being Gatsby or Hugo. Gatsby being a JavaScript framework, Hugo being Go. I don't have time to really go into the details of what's good and bad about these frameworks, but I'll briefly tell you that I happened to choose Gatsby over Hugo originally because I knew JSX already, and I felt like leveraging what I already knew would have been nicer than having to learn Hugo's templating language. The reason why I moved away from Gatsby is because I didn't have even like a dozen blog posts, and it would take Gatsby like more than 60 seconds to build my website on a beefy Mac machine. That wasn't great. And then what really broke it is once I switched to Apple Silicon, so to an ARM machine, it turns out that some dependencies of my dependencies were C, and those failed to build on ARM. And so basically, ironically, my JavaScript website, my JavaScript blog was the one thing that wouldn't work on the new architecture. And so I decided to try out Hugo, which was faster and nice in many ways. I generally like Hugo. And I like it so much that when I started working on the official Zig website, which is another static website that I work with, the first thing that I did was port it to Hugo. What made me want to go away from Hugo is that, differently from my personal blog, the Zig website is a little bit more complicated, which requires you to work more closely with the templating language. And it got to a point where it got very annoying. I'll get more into that in a moment. And so eventually, I made my own static site generator. It's called Zine. Like in Magazine. On the website, there's a yellow box that says, warning, Zine is alpha software. Using Zine today means participating in its development. Let me tell you, the yellow box does not lie. So caveat emptor if you decide to try it. But that said, it's complete enough that the previous websites, including the official Zig website, has been ported to it, and it works well enough. So what is the problem with Hugo templates? It's not just Hugo. I think of those as like the family of curly brace templating languages. Hugo does that. you have handlebars, you have mustache, you have ginger templates. There's a very long list. And I hate these things. Because once you have this templating, well, first of all, you can look at this example, which is a very mild version of the evil things that people can actually do with them. And the whole problem is that, the core problem is that they don't treat HTML as structured data. For them, HTML is just random text. That's good for flexibility because you can use them also to template things that aren't HTML. Lord forgive me for I have sinned. I have templated CSV files with them. I have templated JSON files with them. And I'm going to stop here. I might have done also worse. But if your goal is to write HTML, they are suboptimal because they make it hard for humans to understand if the template is correct or not. They make it hard for tooling to understand that. And so the development experience degrades to the point where you write the template, you watch it run in the web browser, and you kind of eyeball if it looks correct or not. And then the problem is that the browser also has recovery algorithms in case that you feed it wrong HTML. So sometimes you do have a mistake, but you don't see it because the browser tries to correct it at runtime. And this is not great, also because these things break syntax highlighting, they break code navigation, especially once you start templating attributes. So in my opinion, it's a mess. So I wanted to make a templating language that was structured, so that basically would be always correct HTML, so that you can keep the syntax highlighting, you can keep the code navigation, and it also turns out that it's easier for tooling to make sense of a language that is always well-structured. So here you can see it in action. Text is kind of like inner text in a sense. HTML is kind of like inner HTML. Loops evaluates the body multiple times. And I kind of like also the loop plays nicely with certain, integrates naturally with certain elements, certain HTML elements like UL in this case. So this is what I set out to build. I wanted to build a templating engine that would take this as input and output, the HTML that you expected to get from it. Now, my first implementation was using this library. Does anybody recognize the logo? Yeah, okay, a few hands. This is TreeSitter. So I highly recommend you try out TreeSitter. By the way, should be a talk about an LSP, a language server, and I'm talking a lot about parsers. That is because the interesting part of your language server is the parser at the end of the day. Not the only one, but certainly the main one. So I highly recommend you try out TreeSitter, but TreeSitter, I discovered, is not a great parser library for writing parsers for LSP. I don't have time to get too deep into why, but this is a screenshot from the TreeSitter playground. Here you can see there's a div that opens and then a span that opens inside the div, but the closing tags are missing. And with an LSP, you have to deal with partial input. Obviously, that's kind of its main purpose. So if you look at the generated AST from TreeSitter, you will see that it recognizes 2 start tags. That's great. But those 2 start tags, they should be each inside a different element, and the 2 elements should be nested inside one another. But the elements are not there, and the nesting relationship between these 2 start tags is kind of lost. So it turns out, and I think that people that do this a lot kind of know this, except that it wasn't written on the website, or at least I didn't see it. It turns out that TreeSitter is very, very good at recognizing small snippets, small chunks of well-formed syntax, but it's not particularly good. It's not designed to maintain a global relationship between these tiny pieces that it can recognize. That's actually designed to be this way. So this means that TreeSitter, I learned that TreeSitter is great for syntax highlighting, like very great for that, but it is not great for diagnostics. And if you're writing a templating engine or, well, also an LSP, you care about diagnostics because those are basically the main interface to your user. Like your users will write wrong stuff way more than they will write right stuff. But I didn't know that at the time, and so I started trying to produce diagnostics off of the TreeSitter AST. And one day, Togglebit, I don't know if people here know him. He live streams on Twitch. He's one of my favorite streamers to watch. He's very chill. He also does Rust, so if you're interested in Rust, watch him. And he was playing around with my thing, and he was also being naughty and doing wrong things on purpose to see what would happen. And yeah, he did not get great diagnostics while doing that. So Well, I was in chat, we were having fun, so everything was fine. But in a sense, this was like a turning point for me. I don't know if people here, for those of you who have never played Darkest Dungeon, Darkest Dungeon is this game where, well, there are a bunch of characters that go into these dark dungeons, and they are faced with unspeakable Lovecraftian horrors. And they have like a stress bar. They reach their stress bar fills over time as they get more stressed by these monsters, and when it reaches a tipping point, they basically have a transformation. They can get an affliction, like they become a negative trait, they become maybe scared of the dark, or sometimes they also can get a virtue, so like they win against the negative forces that affect them. And that kind of was my point. Do I become a developer that accepts to tolerate bad tooling, or do I write my own parser? That was the point where it was. And luckily, I decided to write parsers. Now, you might be asking, okay, wait, what about other parsers? Okay, maybe TreeSitter is not the right tool for the job, but there's plenty more. Sure, but here's the thing. If you've never done this type of work, you might not think about it. You might not know, but parsers can be, for the same language, they can be dramatically different. And depending on your use case, you will want to use different parsers. In this case, for example, so this is like a screenshot of one random parser that I just found earlier today. I think I did search around for other parsers before deciding to bite the bullet and just write it myself. But the thing is, for example, this parser is a parser that has a minimal DOM implementation, so it cares about runtime DOM stuff, which I don't in a static templating engine for a static site generator. And also, it cares about spec compliance, which is understandable. We mentioned earlier, right, all the things the browsers do to react to wrong HTML. This is a parser that, given what I see here, seems to be a parser that wants to be used inside of a browser, for example. But in my case, I wasn't doing that. I was trying to write a parser for developer tooling. And these things are different enough to the point that in my parser, I don't want to be spec compliant, which might sound weird, but let me show you one example. So, unfortunately, what you're looking at is valid HTML. P tags cannot be nested, so when you open a second P tag, the first one implicitly closes. P is not the only element that can do this, there's a bunch more. And if you are writing a spec compliant parser, you need to accept this. The spec defines exactly how to behave when you encounter this situation. But in my case, I'm writing tooling for somebody who is handwriting their HTML. Zine is a static site generator for people who want to handwrite their own HTML. And the reality is that if somebody is typing out some HTML in an editor and they type this out, that's definitely an error. Like they forgot to close the second element. So if I wanted to be fully spec compliant, I could not treat this as an error. So that's why I decided to break spec compliance whenever situations like this happen. So even though in HTML you can sometimes not close the elements, in my templating language and in my LSP, you have to close the elements because otherwise I wouldn't be able to report this as an error. So here's another thing that I kind of learned along the way. Spec compliance is generally good, but not always the best choice. Because it really depends on what your goal is. And the same applies also to Pastel's law. Pastel's law is the one that says, be liberal with what you accept, be strict with what you output. It's a great rule of thumb. Sometimes, though, there's a lot to gain by being very strict with what you accept as well, especially if it's dev tooling, something that should show you squiggle lines as early as possible. Second thing, which I already mentioned, is that really parsers can be very different depending on your needs. Maybe if you need a parser for a language, maybe there's going to be a parser out there that already does exactly what you need for you. Probably that would not be the case. So keep that in mind. Try to be picky with your dependencies, especially when it's something that is the core thing that your product is trying to achieve, right? It's fine if you outsource something more in the outskirts of what you're trying to do, but something that is core, you should have full control over. And since the parser decides what type of diagnostics you can output, among other things, you really want to have full control over that. So I set out to write my own parser, and I mean, if you wonder what it feels like to write a HTML parser, the answer is it's kind of easy, it's very tedious. A good spec will guide you by the hand all the way through, and the HTML spec does a good job at that. And it's just a lot of it, and you just have to type it out piece by piece. Also, I forgot to say this earlier, but do not get tempted by parser generators. They can be fine sometimes, but if you want to have full control over your diagnostics, and if you're writing tooling, you want to do that, then don't use a parser generator. Type it out yourself. It's not that bad. It's very easy. You just have to put in some work. One thing that I learned while doing this is that it's very nice to copy-paste passages from the spec into next to the code that implements that part of the spec. Like the 10 out of 10, highly recommended. Reference in comments passages from the spec. You didn't see it in the screenshot, but I also copy-pasted links to the specific paragraph of the spec that might not seem much, but it's very good tactical advice, I promise you. So I did this, and yeah, success. Now I have a thing that you give it bad HTML and it complains. So yeah, success. After I had done this, then now it was time finally to actually implement, how can I say, make better my static site generator ecosystem and implement a language server that could finally give me what I couldn't get from Hugo. So because I wanted squiggly lines in my editor as I typed out the templating language. To implement it, I made Zig LSP kit, which is basically the boilerplate from the Zig language server. So it was developed by other people in the Zig community, and I took it out. I basically gutted out all the Zig specific logic and put callbacks in there. And so you implement the callbacks, and then you have a language server that works. I advocated up until now to do things yourself. For LSP, I actually instead would recommend to use a pre-made solution, highly so. It's very boilerplatey, and a decent enough implementation of a library can really take care of all the boilerplate for you, and there is nothing for you to lose there. With some caveats, but I would say this is good enough for most of us. And also at the same time, I'm sure that you can find an equivalent library in your language of choice, most probably. So what does it look like? Again, it's very simple. There's a callback, for example, here for a formatting request. The interesting part is actually the call to the render function, because you have to implement a rendering function for your AST. And then after that, you send the reply to the client. I guess there's this thing where clients kind of would like you to send a diff, not an entire new version of the document, so you have to diff it, but probably if you find LSP library, it will take care of that for you, which actually does in this case, for example. The only piece of advice that I have related to this is please, please, please write this kind of tooling in a low-level programming language, please. It doesn't have to be Zig. You like Rust, do it in Rust, NIM, C. If you have to, C++ is fine. But please do not implement this in a high-level programming language. Parsing should be almost entirely doing some math on a piece of memory. And doing some math should be incrementing a variable, should be one CPU instruction. It should not be 12 heap allocations because you're using something very abstract, please. Because the problem is that if you don't do this, then the tooling will become unbearably slow the moment you try to open a mildly complicated file. So please, thank you. So here's the problem, though, when people start using your thing. So I made my own LSP, and people start using it, and they get crashes because they do things that you, as the creator, would never do. And that is a problem. So if you ever happen to make your own language server, chances are that it will crash on people. So how do you fix this? There is one true way, and that is fuzzing. I cannot overstate how important and amazing fuzzing is. Or rather, actually, when I first heard about fuzzing, I wasn't particularly impressed because, well, fuzzing is this idea that you try random input on your program and then you watch it crash. That did not seem particularly interesting to me in the beginning because, let's say that you have a program like this, where this is an example program that doesn't really do much, but basically there's an assert and you can only trip that assert if the input is a specific password. Now, our programs aren't exactly this, but sometimes there is one particular, very specific type of input that crashes it, and everything else is fine. And so how can a program that just tries things at random ever find your password? And yeah, that's not how it works. But there's a specific type of fuzzing that is instead very interesting, and that's coverage-guided fuzzing. Basically, if you can build an instrumented version of your program, the fuzzer can observe, can know whenever it reaches a new state in your program by feeding it random input. And in a sense, it can start sniffing out how to get into specific branches of your code. And that is amazing, because this program that you see here, the fuzzer can sniff out what the password is through that mechanism. I'm oversimplifying slightly, but it really works. And actually, I will demo this in a moment. So I started fuzzing my own language server. This is the AFL library. It's a very popular fuzzer. There's a lot of stuff on screen. Don't focus on all the numbers. What you care about is this part here. Total crashes 2. So this is a run where the fuzzer had found a crash in my programs, and yeah, it took it 15 seconds to do so. So it can be very good when you have coverage-guided fuzzing. So yeah, my last piece of tactical advice is fuzz your parsers, because fuzzing is awesome when code-guided. Like really, if you don't know about fuzzing, learn about fuzzing. If you've never done fuzzing, try it out. It's amazing. So to conclude, I want to show you a demo. Let me see if I can bring it up on screen. I want to show you some demo that is mostly fuzzing related. So when I started fuzzing my LSP in the beginning, I started by fuzzing the tokenizer. So basically, the tokenizer is the starting point of your parsing process and parsing pipeline, and it deals with individual bytes in the source code. And so the fuzzer could tweak those bytes and get into new interesting states in the tokenizer. But after a while, it had found all the crashes, presumably, in the tokenizer, and so it was now more interesting to test the parser. The problem is that testing the parser requires you first to write correct tokens. And there's a lot of invalid tokens that you will stumble upon by randomly tweaking the bytes. So I needed, at some point, a way of having the fuzzer move from one valid token to another and move between valid states. Also, an HTML tokenizer doesn't concern itself only with one token. It needs also multiple tokens in a row to make sense. So even though it's called a tokenizer, it's more structured than what you would normally think of a tokenizer. And so I ended up writing a tool for this. I call it supergen, and basically you give it a string, and it produces valid ASTs based on that string. So I let the fuzzer tweak the input string, and then that exercises the parser more efficiently by skipping over a bunch of boring states in the tokenizer. So for example, element, attribute, that gives 2 attributes to it. Then I can give it an ID attribute. ID is a special attribute, so that's why it's treated differently. I can give it a value, for example, an empty value, or I can give it a value with also content. Then I can add, another super tag, etc., etc. So I kind of made my own emmet, but for fuzzing. And that's a very valid technique that might help you if you end up doing something like this. So I promised that I said that I would show you the fuzzer running. So let me see if I can change it. So this is the program that I mentioned earlier. I'm going to change that word to squiggly. Sorry, I'm looking at the other monitor, and I don't have very good eyesight, so hopefully I didn't mess it up. I need to build a program, so zig build. What you're not kind of seeing, zig build. So what you're not kind of seeing here, because it's hidden behind just a simple zig build invocation, is that you need to instrument executables, and that's one thing that the Zig compiler is being good at, because it's a compiler toolchain, and that's making it trivial for me. If you are using C and C++, it might be a little bit more involved than this. In any case, I can run the fuzzer, which wants a smaller terminal size, so you can output its window. There we go. Now it's outputting its window. So now I can also show you what its internal queue is as it's trying to figure out squiggle. And so you will never see the full password there on the right side, because once it finds it, it's not like an input candidate anymore, but you will see that the crashes found number will go to red and show 1. So while this runs, and you can see, by the way, this is also running in a very slow mode. This is doing like 3,000 iterations per second. When you set up everything correctly, it can do like 100,000 iterations per second. So it can be much, much faster at figuring things out. But while this runs, I wrote on my phone like a conclusion to the talk. So like I gave you a bunch of tactical advice, like try this, avoid this. Let me conclude with a more like high-level take on all of this. So when I first published SuperHTML, I discovered that it was the first ever HTML language server that reported diagnostics to the user. I wrote a blog post about it, and it got on the front page of Hacker News, and nobody corrected me, so you know it's true. I originally found it a funny thing, but thinking about it more, it's a bit sad that this is the case. Linters do exist, and people can get diagnostics in their editor, but that's usually tooling tied to a specific front-end framework, not vanilla HTML, which leads to people opting to use frameworks, even if they don't really have a need for all the complexity that those frameworks bring. And that's bad in my opinion, not because of an abstract appreciation for simplicity, but because the web doesn't belong just to software engineers. The more we make the web complex, the more we push normal users into the enclosures that we like to call social networks. Don't you find it infuriating when lawyers and accountants fail to clarify how their respective domains work, making them unavoidable intermediaries of systems that in theory you should be able to navigate by yourself? Whenever we fail to make simple things easy in software engineering, and web dev especially, we are failing society in the exact same way. This is not something that startups or big tech can solve for us, because their economic incentives are just too misaligned. So I invite you all to help make the web more accessible, partially as a matter of pride in our craft, and partially because the web used to be more interesting when more of it was made by people different than us. Thank you.
Nice job. Thank you, Loris. All right, let's go have a quick chat. Step into my office.
Oh. Am I fired?
We'll get to it. All right. The first question that I want to ask you is, can you talk about your decision around the BR tag, like BR and then with a closing bracket or closing?
I see. That is not my decision. That is the HTML spec decision. Self-closing tags do not exist in HTML. HTML only has void tags. Unfortunately, if I were less strict and I allowed you to self-close, which is not like a bad thing for void tags, so self-closing BR, self-closing meta, link, and a few other tags, that's not a problem, except it might lead to confusion. But if you self-close a div, you might think that you are closing that div. You are not. The browser will ignore your self-closing slash, and that will be an open tag. Now, combine that with tags that don't have to be closed, and it is the perfect recipe for confusing errors. So no self-closing tags in HTML, because that's how it works.
Good answer. Is there anything really surprising you found while fuzz testing?
Yeah, I'm bad at writing code. Although, no, it's, I was surprised at how good coverage-guided fuzzers can be. It's amazing. Unfortunately, that tech, so here's the problem. If you have a high-level programming language, you can instrument stuff more easily. But that thing is inherently kind of slow. If you do native, like very optimized builds, then it can be much faster, which is great for fuzzing, because fuzzing thrives in trying a lot of things in a very small amount of time. But then you need to get instrumentation. That is complicated. Tool chains suck at this. And so I was very lucky that basically I happened to work on this stuff at the same time that also Andrew Kelly, the creator of Zig, started getting interested. And so he added, at the same time as I was working on things, he added a bunch of stuff to Zig to make instrumentation much easier. And so that's why you can do Zig build. And actually, this is not yet the final point. Next release of Zig will have integrated fuzzing, like the code coverage guided one, so the good kind.
I don't know if it says that I'm better, that I don't need fuzz testing to see that I write bad code. How did you discover or get involved with Zig?
I used to be a developer advocate at Redis Labs, and Redis has the ability to load new data structures implemented by you as dynamic libraries, which is actually a pretty sweet thing. The problem is that you need to be able to produce dynamic libraries, and you need a low-level programming language for that. I did that originally in C, doable, not the greatest dev experience, stumbled upon Zig, really liked it, and then started getting more involved with the community after that.
Well, there is a lot more questions, but not enough time. So we'll keep that conversation going in Discord. Thank you, Loris, for your time, and thank you for the talk. Let's give a round of applause.